Okay, it's a video on square roots, and this is we would compute square root from vertically and crosswise multiply. This is video number 15, part 4 of 5. I split the video in 5 parts, and this is the 4th part. It's a square roots using with vertically and crosswise multiply. Let us continue. Continue with next section here. In this section, we will do square roots from vertically and crosswise multiply. Okay, let's continue here. Let's go look at square root problem. Square root problem is you try to find n is equal to square root of x. Try to find x, square root of x, we say let it be n. Okay. If we were to square both sides, which is n squared is one side and x is the other. Okay, we have n squared is equal to x. Okay, x comes from n times n. Okay, and so n squared is n times n. And how we compute n times n? We remember the vertically and crosswise multiplication. We will use vertically and crosswise multiplication to compute n times n. And how about squares using duplexes? We also have computed squares before using duplexes, which is also vertically and crosswise multiplication. In this section, we will consider square root of perfect squares only and reverse that using vertically and crosswise multiply. Let us continue here. Example, we will take the square root of 22781529. Number of pairs in the number are 4. So number of digits in square root is 4. Okay, and okay, so let's see how we are going to proceed. We know that there are 4 digits in this square root. From the first principles, we know number of digits in square root is 4. We know leftmost digit of the answer, which comes from square tables, and we use 22 to compute the leftmost digit, and that's 4, because 22 is between 4 squared, which is 16, and 25, which is 5 squared. So we'll use a lower number of the 4 and 5. That's a 4 is my left digit here. Rightmost digit is from 9 here, is in the set 3 and 7. 3 plus 7 is 10. So these two are 10's complement of each other. So either it's 3 last digit, it's a 7. And we can say that only when there is a perfect square. So this number is given to be a perfect square, and 4 is leftmost digit, 7 rightmost digit is either 3 or 7. Okay. Let the 4 digits be number A, B, C, D be the square root of this number. That means A, B, C, D times A, B, C, D is 22781529. Let's continue here. First we know A is 4. Question is, where does leftmost 22 come from? So 22 here we have ABCD times ABCD. In this multiplication, where does that leftmost digit number 22 come from? This is the leftmost pair. Okay. So here is my multiplications here. ABCD times ABCD. When we try to compute leftmost pair of these numbers here, we use A times A plus any carry from the right. It comes from vertically multiplication of leftmost digit A times A plus any carry from the right. Okay, let's continue here. Okay. So A times A plus carry is equal to 22. This 22 here must come from A times A plus any carry we got from the right. That means A is equal to 4 and carry is equal to 6. We already know the leftmost digit is 4 and carry must be 6. Carry from right must be 6. Okay? When we multiply, the added number is a carry. Now we are reversing the multiplication. and which is like a division, we may call that a remainder. So instead of carry, we would be calling this a remainder. Okay, let's continue here. So remainder from this step is a 6. So we have 4 as leftmost digit. A is equal to 4, and remainder. Is the problem so far? ABCD times ABCD is 22781529. A is 4, and remainder is 6. We have leftmost digit 4. Okay, now with 6 as a remainder from previous step, next dividend is 67. So next dividend is 67 here. Okay. Now what we will divide by? Where does 67 come from in the multiplication? Okay, so 67 is the next digit of the answer, is the next number on the right. Okay, let's continue here. So we have this multiplication here. We got 22 from 4 by times 4 plus any carry, and now we are next digit to the right, and that comes from these two digits here. We got two columns of the numbers to work on. Okay, let's see what that is. What's that is? 4b plus 4b, which is a times b, and plus any remainder from here is 67. That means b is equal to 8, and remainder is equal to 3. Largest b I can get is 8, and still have a remainder of 3. Let's continue here. So we have a next dividend from with 3 here, and 8 next digit is 38. Okay? So that's my 38. Now let's see where the so the 38 come from, and now we have a 3 digits of to multiply. I know 4 here, 8 here, and a C. We are determining A equal 4, and so far we have B is equal to 8, and C we are trying to find out right now. Okay, let's continue here. So it comes from 4C plus 4C, 8C plus 8 times 8, 64. That means that that's 8C plus 64 plus remainder is 38. Then 8C plus 64 plus R is 38. R 8 when we 8C plus R is minus 26. That means C is equal to minus 4 and R is equal to 6. To keep the remainder positive, because we will be carrying carries from the right would be positive, so we would have a C is equal to minus 4. So that may we have overshot. Oops, we have overshot. How do you correct? Any ideas? Do you remember altered remainders we used in divisions? Backtrack to determining a higher remainder in previous step. So altered remainders was we're going to backtrack and we will determine a higher remainder in a previous. That means we come back to 67 here. A is equal to 4 and remainder is 6. Let's continue here. That means we use a value 8 before, now we'll use 7 here. 8 times b plus r is 67. Okay, let's continue here. Then b is equal to 7 and r is equal to 11. Let's continue. We're using altered remainder. See? That means next dividend is 118. Okay, let's continue here. Okay. Okay, so where the 118 come from? It comes from these three digits multiplication 4, 7, and a C. A is equal to 4, B equal to 7, C we are trying to determine. We tried first time around, we got negative values and we backtrack. So we would give another attempt. So now we have a 2 times 4 times C, 4C here and a 4C here. That's 8C plus 49. 8C plus 49 plus R is 118. Okay. Okay, let's see what happens. 8C plus R is equal to 118 minus 49, which is 69. Okay, that means C is equal to 8 and R is equal to 5. Okay, that would result in an okay. Let's look to the right and see where we are going to get into. That will get me, if I use 8 for C, so C becomes 8. Okay, and the next step, so we would be multiplying these number together. Okay, and okay, if we use a C is equal to 8, R equal to 5, that means we'll end up being using it. Remainder will be 5 here, so the next number dividend will be 51. That means 8 from here, 4 times 8, and 8 times 4, that's 8 times 8 here, plus 7 times 7, 49, plus R is equal to 51. Again, R would be negative, so we will backtrack right away and use a lower value for C and a higher remainder. Let's continue here. That means C is equal to 7 and R is equal to 30. So in this equation here, if I use C is equal to 7, that would get me R is equal to, instead of 5, we'll get 13 here. Okay? That's altered remainders. So we have A is equal to 4, B equal to 7, and C equal to 7, and remainder is 30. Let's continue. Next dividend is 131, right here. Okay, and where does now we don't have a D yet. Okay, 131 comes from where? Comes from here, which is a 4D plus 4D, which is 8D right here. 7 times 7 times and plus 7 times 7, that's this number here. So 8D plus 98 plus R is 131. Let's continue here. 8D plus R equals 131 minus 98, which is equal to 33. That means D is equal to 4 and R is equal to 1. So remember, 1 is a little too short, smaller number, and further we know that it's a perfect square and D is either 3 or 7. Okay, so we would be overshooting using 4. Okay, let's continue here. However, that would mean that at next step, so if I use D is equal to 4, so I will have a 4 times 4 and 4 times 4, which is add them together becomes 32, and 7 times 7 plus 7 times 7 is 98. I mean 2 times 4 times 4 plus 2 times 7 times 7 plus R would be 15. This 1 here and 5 next digit. That's again R would be negative if I use that. So we go back, do alter remainder again. We'll use D is equal to 3, which is consistent with the first principles here. So R would be negative if I use D equal to 4. Okay? That means use D is equal to 3 and R equal to 9. So if a D is 3 here, 8D plus R is 33, then okay, and then remainder would be 9. If we say 8 times D plus R is 33, if I use D is equal to 3, then 24 plus R is 33 and R would be 9. And D equal to 3 is consistent with the. So what do we have right now? We have A is equal to 4, B is equal to 7, C is equal to 7, D is equal to 3, remainder is 9. Okay, and the next dividend is 95. Okay? 95. Let's continue here. And now we have this 4773 times 4773. We use all the digits. We start dropping columns on the left. Okay, so that means that 7 times 3 plus 7 times 3, that's 2 times 7. And then multiply 7 times 7 plus R is 95. So that means this part is 42, this is 49, and plus R is 95. That means 42 plus 49 plus R equals 95. That means R is 4. Okay. So the next step we have a next dividend with 4 here with 42. Let's continue here. Okay. So now we'll drop another column here and 7 times 3 and 7 times 3 is 42. Okay. So then 2 times 7 times 3, next step plus r is 42. That means r becomes 0. Okay. For next step, we have a digit 9 here. Okay, so we have all digits here and we have r equal to 0. Okay. That's 0, 9. Okay. Next dividend is 9, and 9 comes from 3 times 3, so remainder is 0 again. Okay. That means our square root is 4773. Let's continue here. Then the square root of 22, 78, 15, 29 is 4773. Let's look at observations so far we made. Square root of 22781529 is leftmost digit is 4, which comes from square root of 22 from the table. There's no division required here. 100th place of is digit 7, which comes from 67. Remainder 6 here, divided by 8, and that comes divided by 8. So we had to divide by 8 on the second step. In tens place is from 118. Okay, that's this 8 here and 11 remainder. And we did 118 minus square of 7 here, 49. We divided by 8, and that means we did subtract duplex of 7, and we divided by 8. So no division here, first step. Second step, there is division only. And third step, we have subtract and division. Okay. The units place is from 131 minus 98 divided by 8. Okay. So we have 13 remainder from the previous step here, 131 minus 98 divided by 8. Okay. We were subtracting a duplex of 77. There were 2 sevens before third digit, and we got it, and we were dividing by it. So we divide by 8 here, divide by 8 here, divide by 8 here, and 8 is twice of the first digit. Leftmost digit comes from square root and does not contribute to subtracted duplexes. So leftmost 4 is, we don't use 4 in any of the subtractions here. For all other digits, we divide by 8, which is equal to twice the leftmost digit. These digits come from division. So with these first digit 4 came from square root table of squares, and the rest of them need a division. Divide by 8 here, divide by 8 here, and divide by 8 here. Before dividing by 8, we subtracted duplex of digits computed so far and excluding leftmost digit. So leftmost digit 4 is not using any duplexes, and so before we divide by 8, we subtract duplex of digits computed so far and excluding exercises. Okay, so we can do some exercise here. Find square root of the following perfect squares. So note that any number in here you can assume they are perfect squares. Okay, first number is 29192409. Next is 13271449. Next 49491225. Next 174724, and some more. Okay, let's continue here. The first reference is Vedic Math Teacher's Manual, which is elementary level by Ken Williams, and you can get this book from vedicmaths.org, and PDF form is free. Okay. Let's look at next reference now, please. Vedic Mathematics by Bharti Krishna Tirtha Ji. That is the primary reference on Vedic math. That's the original and primary reference, and Bharti Krishna Tirtha Ji is the developer of Vedic math. Let us continue. Next is Discover Vedic Math by Ken Williams. This is the most complete, authoritative, and book with a consistent notation. Okay, let's continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. These have a very readable and cover most of the topics, okay, if not all. Let's continue here. Then Vedic Math for All Ages by Vanna Singhal. This is very readable book and does not cover as many topics as the Glover books.